My name is Yash and I am the student of Marwadi University, currently pursuing BTech in ICT department in second semester at Rajkot. So basically, our department has given us a project on a subject called digital electronics so that we can learn the basics of hardware which the faculties had taught us during the whole semester. So basically, this is a project of our theoretical knowledge to convert it into a working model through troubleshooting ourselves and overcoming many errors which the project will give us and inspired us. So basically everybody in our class has been given a unique project so that they can work on their own at home and learn many things that the book cannot taught them. For example, if any error is coming, then they have to try to fix the connection, check the connection time and again, so that they can find the error at what place at or the error is coming. So let us now move to my laptop screen where I will explain you the whole project of how this circuit looks, how what are the components used in it, and many things. So let us move to our laptop screen. So now we have moved towards our laptop screen. So now I will explain you in brief. So what is an object counter and what is the use of this object counter. So basically what an object counter does is it simply counts the number of object which has passed through it, and this project is guided by our HOD Professor CD Pamaster and Assistant Professor Mehul H. Kantaria, who has helped me in this project. So what is the use of this project? So basically object counters are extensively used in the industries to count the objects that, so normally these are made up of very expensive microcontrollers and processors. For but for small scale industries the cost is a big thing to employ on. So we have created a simple circuit that can count object without using any costly microcontrollers. So what are the components which are used in this project? So basically there are many components used in this project. The first one is IR transmitter, which means the IR LED, which will through its beam on the photo transistor. Then come up the NPN transistor. Then we have used any 555 timer IC. Then the dual up counter CD4518. Then an AND gate we have used. Then we have used a 7 segment decoder and a 7 segment display. Then we have used some few resistor and capacitor. So let us see what the circuit looks like. So basically this is the outcome of how the circuit looks. So as you can see, this is a IR LED, this is a phototransistor. So basically what it will does is this IR LED will throw a beam of light on phototransistor, and then it will go to the any 555 IC where the counting will start, and the main counting will be done in CD4518, and afterward it will through the information to this 7 segment decoder, and then the decoder will display it on the 7 segment display. And we have used this AND gate so that because if the count comes to 9 we have to reset it to 0, so therefore we have used an AND gate. So basically this is how a circuit looks and it will run. So we have used capacitor, this is an NPN transistor, and then it is a capacitor resistor, this resistor capacitor, and many things we have used. So now let us look at how the component works. So this is a IR LED, and this is how it looks, and this is its anode cathode. Then we have used this phototransistor, which is the main thing in it, because when IR LED will through it beams in the phototransistor, the main work of the circuit is this. So then we have used a NPN transmitter. This is its first. This is the what its circuit looks like. It is emitter,
collector base. Then this is the NE 555 timer IC. So the first part of it is ground. Then the eighth is the VCC. Then the discharge threshold, control voltage to reset, trigger pin, output pin. Then the CD4518. It has clock for A part, enable for A, simply for A, and this is for B. Then this is the 7 segment decoder. So as you can see, the BCD output which will come from the CD4518 will be connected here. Then this A B C D E F G, as you can see, this A B C D E F G. Then we have to print is on this 7 segment display. So this is how basically our circuit will look, and this is the outcome. So let me now show you how the circuit will look in real.
So now we have moved towards the implementation in real. So as you can see, this is how the circuit will look in the real. It looks like this. Now this is a IR we have used, and this is the photo transistor, then resistors, capacitor, any 555 IC, then CD4518, then decoder, AND gate and decoder, and 7 segment display, and this is the ground, and this is the 5 volt. So basically now we will see how this will work. So now this is an object, for example, and now I will put this object here. As you can see, I have put the object and the count is 2, and I will try it again. Then as you can see, it is working very perfectly, as you can see. So this is how basically this project runs. So thank you. In the end, I would like to conclude this project, and thank you very much for listening to me.